Hello. I'd like to discuss quadratic equations, and I've used an Excel spreadsheet, which I find very useful to help students understand a quadratic equation or other equations for that matter. A quadratic equation has x as high as the second power, y equals x squared plus bx plus c. And one thing I like students to understand is that the c is a constant. So if we just have c, y would be a constant. And let's just see what it would look like. Let's let just c have a value of 5. And you can see that y is constantly 5. Let's put c back to 0. And now let's let b have a value. Now, let's say we just have y equals bx. We let a and c equal 0. Let's say y equals 2x. And you can see we have a line that goes through the origin, and it has a slope of 2. Now, the doesn't look exactly like the slope is 2, but the axes have different values. If we change the c value to 1, we see that the line doesn't go through the origin, it goes through 1. The y-intercept is 1. So you have a linear term here, a constant term, and then your quadratic term. So let's take a and b or b and c and set them equal to 0, and just put a equal to, let's just put it equal to 1. So y equals x squared. You can see this is a parabolic curve, and it goes through the y-axis at 0. And if we put a linear term in there, let's put a 2 for b. You can see that it's no longer symmetric with regard to the x-axis because we've added to the original function a straight line function, and the 2 it jacks up this side of the equation and reduces this side. And finally, let's let c equal 2, and now it goes through the origin. Now, the quadratic formula can be derived. Y equals minus b plus or minus the square root of b squared minus 4ac over 2a. It's easily derived. You can go to YouTube and do a search, and you'll find lots of examples. Now, the roots of a quadratic equation are the values of the equation that go through the x-axis. And you can see none of this curve does not go through the x-axis. It doesn't intersect the x-axis. So let's make c a little smaller so that it does. Let's make it minus 5. Okay, and you can see it goes through the x-axis here and here. It has 2 roots, and the roots are real, obviously. These are the value of the roots. I have a program to give me the roots. So students can visualize that in order for there to be real roots, the quadratic equation has to go through the origin. So now if we make x or c a positive value, it may not go through the origin, and you can see that it doesn't. So now you have 2 imaginary roots. And really what determines it to have an imaginary value is b squared minus 4ac has to be negative. So it's the square root of a negative number, which is imaginary. So the first root is minus 1 plus 2i, and the second root is minus 1 plus 2i. I think it should be minus 2i. I think it should be minus. I'll have to check. I probably made a mistake in programming this. Okay, so we have a nice way of visualizing quadratic equations using Excel. I would urge you to try and have your students use something like this to have a good understanding of quadratic equations. They can play around with the numbers and see what happens to the function, and maybe even predict what would happen. What would happen if we made b 0? It's going to be symmetrical again, but it doesn't go through the origin because of the constant value of 5. We change that to minus 5. We do have 2 roots, and they are plus and minus 2.236. Okay, so thank you for your attention, and I'll see you next time.